Hi everyone, this is going to be my first video in my playlist about chemical bonding, and today we're going to be talking about valence electrons, the octet rule, and Lewis dot diagrams. Although most of you have probably covered these three subjects in your introductory chemistry courses, we're just going to review them so that we can go into more detail about more advanced bonding topics such as resonance structures, which I'll be covering in later videos. So let's get right into the subject of valence electrons. So there are two types of electrons when you look at an atom. You look at core electrons and valence electrons. Valence electrons, which we'll be talking about today, are defined as the electrons that are in the highest energy sublevel. What I mean by that, if we look at this periodic table, we can look at the quantum principal energy level from 1 through 7 on our periodic table, meaning hydrogen would have its atoms in its atoms farthest away from the nucleus in its first energy level, lithium the second, sodium the third, and etc. Valence electrons are these electrons that occupy this highest energy level. So, as I said before, core electrons are simply non-valence electrons, or electrons that are not in this highest energy level. So, what's important in chemistry is determining the number of valence electrons. So, let's look at calcium atomic number 20. So calcium, which I'll write here, has the atomic number 20 with the electron configuration of Ar, argon, and then, as I said before, we're in the nth, the fourth principal energy level. So we will have 4. We have to occupy the s orbital first, s, then plus 2 electrons away from argon, 4s2. So how many valence electrons does calcium actually have? Since we have 2 electrons in the 4s subshell, the energy level that's farthest away from the nucleus, calcium will have 2 valence electrons. Let's take a look at fluorine on the other side of the periodic table. Fluorine, which has 7 electrons, which I'll show you right now, is a very electronegative and very reactive element. I'll talk about why it's reactive later on in this video. To prove why it has 7 valence electrons, let's look again at the electron configuration of fluorine. We'll begin with 1s2, 2s2, 2p. Now, how many in this p subshell? We'll need 5, because we are 1 away from neon, from its noble gas electron configuration, 1 electron from 2p6, so a 6 minus 1 will give us 5. Now we know this is the correct electron configuration because 2 plus 2 plus 5 is 9, which is the atomic number of a neutral fluorine atom. So now I said it has 7 valence electrons. How can we show this? So in the highest energy level, 2, we have 2 plus 5, 7 valence electrons. So then as a quick example, we can find valence electrons using group numbers. So we have group 1, 2, 3, 4, 5, etc. So we can say that nitrogen will have 5 valence electrons because it is also in group 5. And we can say oxygen has 6 valence electrons because it's in 6, etc., etc. So you might be wondering, why is this important in bonding? So valence electrons are the only electrons in an atom in either ionic or covalent bonding that actually participate in chemical bonding. Core electrons in bonding have no role. So in formation of an ion and ionic bonding, the number of valence electrons determines whether it will gain or lose electrons. Now, ions are a subject for a different video, but they're obviously very pertinent here. So it would be very favorable to lose these 2 electrons here to give us the noble gas configuration of argon, and here's why. If we take a look at the orbital diagram of calcium in the 4s subshell, we have this, then 4p, we have nothing, nothing, and nothing. So it would be much more favorable to lose these 2 electrons to get a stable argon subshell, or a stable argon electron configuration, rather than to gain 6 more electrons occupying the 4p subshell to achieve the noble gas configuration of krypton. So, as I've said before, it's favorable to have a noble gas configuration. This is where the octet rule comes in. Octet rule states that atoms will tend to have a full orbitals with 8 valence electrons. This describes perfectly these noble gases. These all end in N, the principal energy level P6. So we have 6 plus 2 from the S. 6 plus 2 is 8. This gives us the octet rule. So for example, calcium will form a 2 plus ion. Because it will be isoelectronic, it will have the same number of electrons as we go up here as argon, as I've said before. Once we lose these 2 electrons, it will end in 3p6, same electron configuration. It will have a stable octet of valence electrons. The same is true with fluorine, which forms the fluoride ion, which must gain 1 electron from its orbital diagrams. We would have 1s, 2s, and then let's complete the 2p subshell with nothing here, 2p. Favorable to gain this 1 electron to complete the octet. In its highest energy level, 2, we would have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this is why the octet rule is important. So now we're going to talk about Lewis dot diagrams, which are an important shortcut for writing the number of valence electrons that an atom has. Lewis dot diagrams are very important in drawing Lewis dot structures, which show bonding structures, which again we'll cover extensively in later videos. So let's use the examples that we have here, plus one more. We'll use nitrogen. So when we draw a Lewis dot structure, we'll start with just the atom. Now to draw the Lewis dot structure of a neutral atom, we have to start with 1 electron here, and then place 1 electron on the opposite side. Calcium will have 2 valence electrons, meaning it has 2 electrons that will participate in bonding. So this is the final answer if you're asked, draw the Lewis dot structure of a Lewis dot diagram of calcium. Now fluorine, as we've said, has 7 valence electrons and must gain 1 to have a complete octet of 8 valence electrons. So we'll start on this side, go to the other, then back around again. And we're left with 1, 2, 3, 4, 5, 6, 7 valence electrons. Our final answer, 2 valence, 7 valence. Now, as I've said before, our final example will be nitrogen. Nitrogen has 5 valence electrons, meaning it can form 3 bonds with each of its 3 covalent bonds with each of its single electrons, which again we'll cover more in a later video. We'll start with 1, go to the other, go to the other, go to the other, and here. 1, 2, 3, 4, 5 valence electrons. This is our final answer. As I've repeated many times in this video, valence electrons are the only electrons that are active in chemical bonding. So the number of valence electrons determines the type of bond it will form and how many of those bonds, single, double, or triple, that specific atom can form. But again, that's a topic for a later video. So we've covered valence electrons, the electrons in the highest energy level of an atom, the octet rule stating that it's most favorable. Usually there are exceptions, which I will get to when we talk about formal charge and resonance. It's most favorable to have a complete octet of valence electrons, and Lewis dot diagrams, which are shortcuts to represent how many valence electrons an atom has. Thank you, and my next video will be covering Lewis dot structures and how these valence electron Lewis dot diagrams play a role in more advanced bonding topics. Thank you.